Hello guys, in this video I want to discuss the concept determinant. We know if we're given a matrix A with element 2 by 2, then the determinant of this matrix is the following expression. You take the product of element on the main diagonal and subtract the product of the element of this diagonal. So you will get the result. In this video I'm going to discuss determinants 2 by 2, but we can generalize the idea of determinant into third dimension such as n by n. But I want to show you the geometric meaning in 2 by 2 case, so we can think about n by n case by using our analogy in 2 by 2. So what does determinant mean? So let's say we're given Cartesian coordinates, and in these Cartesian coordinates we're given two vectors, e1 and e2. And the coordinates of e1 is 1, 0, and coordinates of e2 is 0, 1. And then what we can do, by using these two vectors, we can create a square, and we can find the area of the square. And let's name the square area is a1, and we can see since this length is 1 and height is 1, then area is 1 times 1 equals to 1. Okay, but what we want, how we gonna get determinants? By giving just these two vectors and giving the square that which is created by these two vectors. We're gonna deform our vectors. And how we're gonna deform? We're gonna deform in the following way. I'm going to talk about this in my next video. I'm going to deform them by using, let's say, B, where B is my linear transformation. But let's forget about linear transformation so far, and we can think about our transformation in the following way, that we have vector e1, and we transform this vector e1 to some vector, let's say vector x, with coordinate x1 and x2. And in the following way we also have vector e2, which we're going to transform to the vector y with coordinates y1 and y2. And there is a lot of rules about linear transformation, what is linear transformation, but let's so far just think that we took a vector e1, and in some sense we just move this vector e1 in the following direction. And we move and stretch our vector. So right now we have new vectors. We have vectors x and vectors y. And when we have these two vectors, we can see that original square is actually got deformed in the parallelogram. And we're going to get the following parallelogram. And what we can do, we can find the area of our parallelogram. And let's say that our area is equals to A2. But we don't know what is our area is. So our goal is find out what is our area. And the coolest part about this topic is that by finding what is our A2, we're gonna get the notion of our determinant. So we're gonna find that our area is gonna be actually equals to this expression. So what is determinant? The determinant is how the area of this square is gonna be changed under linear transformation. And so basically we're saying we're looking for the difference between this area and this area. So let's find what is our value for area A2. How are we going to approach this? We're going to use the concept that I use for proving the dot product formula, and you can find this proof in my previous videos. So basically what I'm saying let's create two vectors, alpha and, let's create two angles, alpha and beta. And then if we have two vectors alpha and beta, we can express our area by using the following formula, where x is the length of vector x, where y, absolute value of y is the length of vector y, and sine beta minus alpha is this angle, because we know that this angle is going to be angle beta minus angle alpha. And why I'm using this formula? Because this is a really famous formula for finding area of the parallelogram if we have the side A, the side B, and angle gamma. So then this parallelogram is going to be area equal A times B times sine. Okay, but why I'm using this formula, how I'm going to apply this formula to prove what is my determinant is. I'm going to use the following property. So we can see this is our vector x with coordinate x1 and x2. And this is our angle alpha. And we know this is the length of this side is x1, and the length of this side is x2. And the length of this side is absolute value of x. So what can we do? We can express our cosine and sine alpha in the following way. By definition of cosine we know. And by definitions of sine we know. So from here I can see that I can express my x1 to be equal absolute value x cosine alpha, and my x2 to be equal absolute value of x and sine alpha. And what is the coolest part? The coolest part is that right now we can express our value for x vector as x1 times x2 equals to. So we got that our x1 is equals absolute value x cosine alpha and x2 absolute value x sine alpha. In the following way, we also can show this is true for vector y. And by using the same procedure, we can get that our vector y is equals to the following expression. And why do we need this? Why do we need this? Wait just for a second. And then I'm going to rewrite my area, my formula for my A2 area. By using the definition of sign of difference, I can write this is equals to the following expression. It's going to be sine beta times cosine alpha minus cosine beta times sine alpha. Then what I want to do, I want to regroup my terms. So what I'm going to get is, you can see when I have beta, I want to group this with y. So I will get absolute value of y times sine beta and absolute value of x times cosine alpha minus absolute value of y times cosine beta, absolute value of x times sine alpha. And let's pause for a second. And you can see that, or I don't want an orange one. Okay, red one, cool. And you can see that this thing is actually equal to y2. This expression is equals to x1. This expression is equals to y1. And this expression equals to x2. So what I get, I'm gonna get that my area that I'm looking for is actually equals to x1 times y2 minus x2 times y1. And miracle. Why? Because I actually got this formula. So this thing is actually equals to determinant of x1 and x2, y1 and y2 equals to determinant of A. And this is super cool. So basically, the meaning of the determinant is how our area of unit square is going to be changed under linear transformation. So we actually find the value by which quantity our area of unit square is going to be changed. So this is the geometric meaning of determinant. Thank you guys for watching, and in the future video I'm going to continue discuss this how to define addition and multiplication in natural numbers, and I'm going to prove the following property of the natural numbers. And also I'm planning to do the series of discussing such concepts as linear algebra, number theory, set theory. I'm planning to complete the construction of natural numbers, and then I want to construct integers and rational numbers, and the following my goal of that section is going to construct real numbers. This is super interesting, so I hope you're gonna enjoy my videos. Thank you for watching.